In 1938, a quiet man walked into the Air Ministry carrying sketches that could have changed the future of air warfare. His name was Geoffrey de Havilland, and he believed he had designed the fastest bomber the world would ever see. But the moment he stepped into the office, he felt it: the polite smiles, the raised eyebrows, the silent judgment. Before he even sat down, his idea was already considered nonsense. To the officials, his drawings belonged in a museum, not a factory. At that time, RAF doctrine was practically a religion. Air Marshal Hugh Trenchard's theories ruled everything. Bombers didn't need speed, they needed guns, armor, and crews packed into metal fortresses. The Bristol Blenheim, Wellington, Whitley, these were the future. Heavy, metal machines covered in turrets and gunners. And then de Havilland suggested something outrageous: a wooden bomber. No turrets, no gunners, just a pilot, a navigator, and two giant Merlin engines pushing the aircraft faster than enemy fighters. The officials listened the way someone listens to a confused relative talking about cavalry charges in a tank war, with patience and disbelief. Their reasons felt solid in 1938. Metal was modern, wood was old. The Schneider Trophy races proved metal aircraft were faster. Germany was building sleek, all-metal bombers. America had the mighty B-17. Wood was for toys and antiques, not war. So de Havilland left the building with the same sketches he walked in with: ignored, dismissed, forgotten. Britain wanted metal fortresses, not wooden experiments. But September 1939 shattered every assumption. When Germany stormed into Poland, their tactics exploded the old ideas. It was speed, not heavy gun turrets, that shocked the world. And when France fell in 1940, RAF bombers paid the price of outdated thinking. Blenheims and battles were torn apart by German fighters. Their defensive guns were useless. Dozens of crews died in slow machines that couldn't escape or defend themselves. Meanwhile, Britain faced another disaster: an aluminium crisis. Hurricanes, Spitfires, Wellingtons, everything required metal. But after Norway fell and U-boats hunted Atlantic convoys, aluminium shipments dropped sharply. Britain simply couldn't build enough metal aircraft. Then the Blitz began. Cities burned. Factories were smashed. Aluminium demand skyrocketed. Supply collapsed. And suddenly the future of aviation was too expensive to produce. Desperation forced the Air Ministry to reopen doors they had slammed shut. Someone remembered the wooden bomber. In November 1940, Geoffrey de Havilland received a call he never expected. The same officials who once dismissed him now wanted to talk, urgently. This time they asked different questions. How much timber do you need? How fast can you build it? Can furniture factories help? The ministry gave a cautious green light. One prototype. Low priority. Barely a vote of confidence. They didn't even call it a bomber, only a high-speed reconnaissance aircraft. But de Havilland didn't argue. He finally had his chance. His team at Hatfield began work at once. Chief designer Ronald Bishop faced a bold challenge: create a wooden structure strong enough to beat metal aircraft. And the solution came from an unexpected place: racing yachts. Bishop designed a wooden sandwich fuselage, birch plywood on the inside and outside, with a balsa core in between, like a strong but feather-light shell. Casein glue bonded the structure so tightly that the wood itself failed before the glue did. And slowly, the impossible took shape. The engineering calculations revealed something remarkable. The calculations hinted at something extraordinary. And the deeper the engineers looked, the more unbelievable it became. A birch and balsa sandwich panel weighed nearly 1/3 less than an aluminum sheet of equal strength. Even better, it was naturally stiff and rigid. Metal bends and flexes under load. The Mosquito's wooden monocoque shell held its shape because the separated layers created a powerful moment of area. In simple terms, a little wood could carry a lot of stress. The wings shared the same philosophy. Instead of heavy metal spars, engineers laminated thin spruce strips into strong box-shaped beams. The leading edge used plywood, the trailing edge used spruce and ply, and the entire wing was covered in birch skin. It was light, strong, and shockingly simple to build. And unlike metal aircraft, full of rivets, heat treatments, and specialist tooling, the Mosquito could be built by woodworkers. The fuselage formed in two halves inside concrete molds. Workers laid the inner plywood, added balsa blocks, then applied the outer skin. When the mold heated and pressed it all together, the glue cured into a single seamless shell. This solved a massive wartime problem. Britain didn't have enough trained metal aircraft technicians, but it had thousands of carpenters, cabinet makers, piano builders, and furniture craftsmen. Suddenly, workshops that once made dining tables or cricket bats were building bomber parts. Production became so spread out that German bombing couldn't stop it by destroying one factory. When the first structural tests began in early 1941, the results shocked even de Havilland's team. The wooden components survived forces far beyond expected limits. Wood soaked up vibration, made the aircraft quieter, and even handled damage better, splintering instead of cracking like metal. On November 25, 1940, the prototype flew for the first time. Test pilot Jeffrey de Havilland Jr. expected a difficult flight. What he got instead felt like flying a fighter. The Mosquito climbed fast, turned smoothly, and felt alive on the controls. Speed trials confirmed the miracle. 388 miles per hour level flight, touching 400 miles per hour at altitude, faster than the hurricanes meant to protect it. But the Air Ministry still doubted it. Speed was impressive, yes, but could it survive real combat without a single gun? There was only one way to find out. The first combat tests. In July 1941, the RAF's No. 1 Photographic Reconnaissance Unit received the first operational Mosquitoes. These early versions carried no bombs, just cameras, and depended entirely on speed and height for safety. Squadron leader Bert Clark took the Mosquito's first real mission on September 15, 1941. His target lay deep on the French Atlantic coast, Bordeaux and La Pallice, home to German U-boats. Previous reconnaissance Spitfires barely had the range to attempt it. But Clark soared to 23,000 feet and crossed the channel. German radar spotted him and launched interceptors. Messerschmitt 109s climbed hard, but the Mosquito simply pulled away. Clark completed the mission calmly, outrunning everything sent after him. 2 months later, November 15, 1941, came an even bolder test. Flight Lieutenant Alistair Taylor and his observer Sergeant Sambutz flew straight over northern France in broad daylight. Their route passed Paris, the Channel ports, and multiple Luftwaffe airfields. German controllers scrambled fighters from 3 bases, but none closed the distance. At altitude, the Mosquito cruised at a speed the 109s couldn't sustain. Taylor photographed every assigned target and returned safely after 3.5 hours, never firing a shot, never needing to. The RAF's doctrine turns upside down. The implications hit the Air Ministry like a shockwave. Everything they believed about bomber design collapsed. Every turret removed saved weight that could be turned into extra speed or more bombs. The Mosquito proved you could remove all guns if you were fast enough. Luftwaffe analysts refused to believe the numbers at first. A wooden aircraft, carrying combat loads, flying 400 miles per hour at 30,000 feet. But pilots in the field knew better. The Mosquito wasn't just fast on paper, it was fast every minute of a mission. German fighters like the Messerschmitt 109F could reach 390 miles per hour at sea level, but combat didn't happen down there. At 25,000 feet, the 109 struggled to reach 370 miles per hour, while the Mosquito cruised effortlessly above and beyond it. And the Germans were only beginning to understand the problem. The situation was even worse than the numbers suggested. For a German fighter to reach its listed top speed, the pilot had to push the engine at full power, burning fuel so fast that he had maybe 15 minutes before risking engine failure over occupied territory. The Mosquito pilot, meanwhile, cruised comfortably on normal settings. With 2 Merlin engines delivering 1,400 horsepower each, the lightweight wooden airframe had power in reserve. If a German fighter appeared, Mosquito crews simply nudged the throttles forward and watched their pursuer fall behind. They climbed quicker, held speed better at altitude, and accelerated faster than anything Germany fielded in 1942. Germany hoped the new Focke-Wulf 190A, entering service in late 1941, would finally solve the problem. It was an excellent high-altitude fighter and, on paper, capable of 408 miles per hour. Luftwaffe pilots expected it to catch the wooden nuisance. It didn't. The 190's top speed depended on perfect conditions and heavy boost that strained its radial engine. In real interceptions, climbing from low altitude to meet a Mosquito already high and fast, the advantage vanished. Reports from Jageschwader 2 and 26 repeated the same line through 1942. Target escaped due to superior speed. Some pilots never even closed the range before the Mosquito walked away. Altitude only made things worse. Mosquitoes operated between 28,000 and 32,000 feet, where German oxygen systems struggled and cockpit heaters barely worked. At minus 50 degrees Celsius, many Luftwaffe pilots fought numb hands, dizziness, and slow reactions. Mosquito crews, with better heating and oxygen gear, remained alert and comfortable. Reichsmarshal Göring himself exploded in anger after watching gun camera footage from January 1942. In the film, a Focke-Wulf pilot pushed his fighter to the limit, yet the Mosquito still pulled ahead. Göring demanded answers. None of his engineers could explain why a wooden British aircraft outran Germany's finest machinery. The psychological toll was enormous. Luftwaffe pilots who once dominated French airspace in 1940 now faced an enemy they simply couldn't reach. RAF photo recon missions crossed the Reich in broad daylight, untouched. Failed interceptions wore down morale. Some German pilots eventually stopped chasing Mosquitoes altogether. By late 1942, controllers often refused to scramble fighters for high-altitude, high-speed contacts. They knew it was pointless. A wooden aircraft that could become anything. The Mosquito's construction gave it another advantage: adaptability. Metal aircraft needed redesigns, new tooling, and long engineering work for role changes. The Mosquito didn't. Its modular wooden structure meant factories, many of them furniture workshops, could adjust molds and jigs quickly. Photo recon versions came first, but by late 1941, the Air Ministry realized the aircraft could be almost anything: night fighter, pathfinder, bomber, anti-shipping strike aircraft. The night fighter transformation. Britain desperately needed better night defenses. German bombers hit cities relentlessly, and the Bristol Beaufighter, though carrying radar, was slow and heavy. Mount the same AIMK-4 radar inside a Mosquito, however, and everything changed. Number 157 Squadron received the first night fighter Mosquitoes in April 1942. The wooden nose allowed radar waves to pass cleanly, and 420mm cannon in the belly gave it devastating punch. Wing Commander John "Cat's Eyes" Cunningham, already famous, claimed his first Mosquito night victory on May 15, 1942, destroying a Heinkel He-111. The Mosquito closed gaps the Beaufighter never could. It climbed faster, cruised higher, and overtook bombers previously thought unreachable. By late 1942, Mosquito night fighters were so effective that the Luftwaffe abandoned daylight raids on Britain and drastically reduced night operations. The Pathfinder and Bomber Revolution. Bomber Command's new Pathfinder force, created in August 1942, needed fast, survivable aircraft to mark targets deep in Germany. Heavy bombers were too slow, medium bombers too inaccurate. The Mosquito was perfect. In November 1942, the first bomber Mosquitoes joined Number 8 Group. They carried a 4,000-pound cookie bomb, small compared to Lancasters, but ideal for precision marking. On January 30, 1943, 3 Mosquitoes struck Berlin at noon, during a major Nazi ceremony where Göring was scheduled to speak. The attack humiliated the Luftwaffe and proved the city could be hit in daylight by aircraft they couldn't even touch. Anti-shipping power, the Setzi. Coastal Command soon adopted the Mosquito as a strike aircraft. The fearsome FB-Mk6 Setzi variant mounted a 57mm cannon, essentially a tank gun, capable of punching through a U-boat's pressure hull. Rockets and 20mm cannon added even more firepower. On March 10, 1943, Setzi Mosquitoes severely damaged U-976, forcing it back to port. Metal aircraft couldn't shift rolls this easily. The Mosquito could. Operation Jericho, the impossible mission. The most daring operation of all was the raid on Amiens prison. Over 700 prisoners, including resistance members, waited for execution. The walls were 6 feet thick. A normal bombing run would kill everyone inside. Group Captain Percy Pickard believed Mosquitoes could do what no heavy bomber could: hit the walls with precision from rooftop height. The plan used 19 Mosquitoes in 3 waves. Break the outer walls. Smash the guard barracks and German quarters. provide backup strikes if needed. On February 18, 1944, under clear skies, the Mosquitoes lifted off from RAF Hunsdon at 1,100 hours, skimming just above the channel to stay below German radar. French villagers near Amiens heard the approaching roar long before the aircraft appeared. Merlins at full power, streaking barely above trees at nearly 300 miles per hour. Leading the first wave, Pickard brought his Mosquito in at barely 50 feet. The prison rose ahead, its stone walls stark against the snow. German gunners had only seconds to react before the aircraft were already overhead. At 11:11 a.m., the first bomb smashed into the eastern wall, blasting open a gap in 6 feet of stone and stunning guards across the compound. The second wave struck only moments later. Their 500-pound delayed fuse bombs punched through roofs of the guard block and administrative wing before erupting inside, collapsing entire sections and killing or disorienting the personnel stationed there. Inside the cells, prisoners finally understood what the deafening blasts meant. This was a rescue. Those closest to the breach scrambled through the broken masonry, while others used tools scavenged from workshops to break open locked doors. Above them, the reserve wave circled, ready to make follow-up attacks. Pickard radioed confirmation that both breaches were successful. Moments later, climbing out over Amiens, his Mosquito was struck by ground fire and crashed. Both he and his navigator were killed. 2 other Mosquitoes were lost to FW-190s scrambling from nearby airfields, but the mission had already achieved its purpose. Of more than 700 inmates, 258 escaped. Nearly 200 reached freedom with resistance help, including several leaders scheduled for execution the next morning. The success at Amiens showcased a capability no other Allied aircraft possessed: precision bombing at high speed and low level. German reports from mid-1943 revealed deep frustration. Intelligence summaries described the Mosquito as the most dangerous aircraft in RAF service, noting bluntly that fighters could not reliably intercept it. With every failed chase, the Luftwaffe's confidence eroded further. German engineers were ordered to study every captured Mosquito fragment. They dismantled wooden sections, analyzed the sandwich structure, tested glues, and tried to understand how a wooden airframe could outperform their best metal fighters. This triggered several desperate German wooden aircraft projects. The most ambitious, the Focke-Wulf Ta-154, was intended as a high-speed wooden interceptor. But poor quality adhesives, inconsistent wood supplies, and structural failures doomed it. Joints split under load, moisture seeped into untreated surfaces, and dangerous flutter appeared in test flights. The project collapsed before entering service. The deeper problem was industrial. Britain had a vast peacetime furniture-making network that seamlessly transitioned into aircraft production. Germany had no equivalent. Their factories were built for metal construction, while skilled woodworkers were scattered, many conscripted or tied to other industries. Even Heinkel's wooden fuselage, He-119, failed to match Mosquito performance and was abandoned. The last-ditch Bachem Ba 349 Natter, essentially a manned rocket made of cheap wood, disintegrated on early flights and demonstrated how far German design had fallen into desperation. The Mosquito's success came down to meticulous British preparation. De Havilland's engineers had spent years perfecting resin glues, curing temperatures, and controlled grain wood selection. German attempts came too late, under bombing pressure, with inferior materials and overstretched engineering teams. By the time the Luftwaffe recognized the danger, it no longer had the resources or stability to respond. Operational results proved everything. From 1941 to 1945, Mosquito bomber squadrons flew more than 28,000 sorties and recorded the lowest loss rate of any RAF bomber, 0.63%. Lancasters lost double that, and Halifax's more than triple. The primitive wooden aircraft was both faster and safer. Production was equally astonishing. Britain built more than 7,700 Mosquitoes. Canada added over 1,000 more, and Australia contributed additional units. In total, 43 distinct variants emerged from the same basic airframe: night fighter, pathfinder, photo reconnaissance, anti-shipping, meteorological, trainer, and more. No metal aircraft could be reconfigured so easily. In combat, Mosquitoes destroyed more than 600 enemy aircraft, marked targets for thousands of heavy bomber raids, carried out pinpoint attacks on Gestapo headquarters across Europe, hunted U-boats, and executed raids like the one at Amiens. Missions impossible for slower, heavier aircraft. They were economical too. cheaper than a Lancaster, requiring only 2 crew instead of 7, and capable of flying multiple sorties per day. Even when German jets appeared in 1945, the Mosquito remained operationally competitive. Fast, versatile, easy to maintain, and able to use forward airstrips where jets could not. In the end, the RAF planners who once dismissed de Havilland's wooden aircraft didn't need to apologize. The war itself delivered the verdict. The wooden museum piece they rejected became the aircraft they depended on. Its success overturned long-held assumptions about aircraft design and proved that innovation often comes from challenging what everyone else considers obvious. The Mosquito finished the war still in frontline service, still feared, and still unmatched in its combination of speed, precision, and adaptability. Not bad for a wooden idea the experts laughed at.